Okay, so what's your name, your school background, and how you ended up here at Texas?
My name is Jeffrey Suarez. I have 2 bachelor's and master's that I received from California State University, Northridge in California. My bachelor's are in psychology, one in kinesiology, exercise science, and my master's is in exercise physiology. I'm currently here at the University of Texas pursuing my doctorate in exercise science with an emphasis in exercise physiology.
Cool. What research are you involved in?
Right now we are taking a look at a few ergogenic aids and the benefits that they have for increasing protein synthesis and reducing protein degradation with the hopes to increase muscular strength, hypertrophy of the muscle, and I'm personally looking at the effect of an ergogenic aid on glucose metabolism and insulin sensitivity.
Cool. And how do you test this?
Well, using an animal model is best right now. So we have to design our experiment to try and best answer the question, which is our hypothesis, of course. And from there, what we do is submit it to IACUC. IACUC hopefully agrees with how we've designed our study. And from there, we just do a simple supply of the ergogenic aid, and hopefully from there, glean out the information to give us something.
Cool. How does a background in biology help with this research?
Well, it's actually kind of important to understand molecular signaling. So when we're looking at, say, insulin, we need to know the factors that are responsible for triggering insulin's release, how insulin behaves, how long it even stays in the system. And it becomes a design issue so that if we want the animals at resting blood glucose levels, we have to fast the animal. Because at some point, if they eat, there might be a rise in blood glucose, there might be changes in insulin, and so these baseline values are altered, which would then cloud our data. So, understanding how the organism actually behaves at a molecular level, as well as just the systemic reactions to its environment, all play contributing factors. And stress is something we have to look at when we design our experiments so that we reduce the effects of certain hormones that might otherwise compromise our results.
Do you use mice?
I don't use mice, but some of the faculty do use mice.
Okay. How long have you been doing this research?
I started in 2006, so almost 10 years now.
Here at UT, or
No,
did
here
you bring
at UT I started in 2012 in January, and I've been working in animal models since I was an undergrad.
What do you like about this research?
It's like a Rubik's Cube that fights back. That's the way I like to describe it. You seriously think that you have it nailed down, that you understand it. It seems pretty simple, it's straightforward, and 9 times out of 10 you're right. But then when you try to really pin it down and be able to describe it, there's so many cofactors and variables that come into play that really all you can say is, at this one moment in these specific animals, given this perfect paradigm that I had, this is what I found. Is this applicable? Hopefully. Is it repeatable? Certainly. But can we apply that to other people? I don't know. Sometimes we can. Sometimes we take something that worked beautifully in animals and put it in people, and we get nothing.
Okay, so you have tested on people before?
Mm-hmm.
Is there anything else about your research that I haven't asked that you thought is pretty important, or that you find interesting about it?
You get really good at multitasking. You have to be. My remember I did something on my master's where I wrote out how long it took to cast gels, how long it took to incubate, how long it took to run the entire process for SDS Page in Western blotting analysis. And it was something like 72 hours for one gel, which was just staggering when you think I have to do 12 gels and I have to do 12 proteins. So it starts to become a massive undertaking in just hours to complete. But then when you sit there and go, well, I can do 12 gels at one time, the next thing you know, it gets cut. And then if I do this here, this gets cut even more. And so it ends up only being 72 hours for doing all of one protein, which isn't terrible, but at the same time, it is a long time. So the time commitment really is the biggest factor. And I've heard sometimes you kind of have to enjoy the self-punishment that you inflict on yourself to be in research, because no one's forcing you to do it, and you're going through the agony of the man hours, time away from home, all because you want an answer to a question.
Is it required to do research by your doctorate program?
Some programs, yes, are mandatory, like mine, and others are not.
Okay, good. Just want to make sure. So would you suggest to people to do research or no?
I think getting into research early is a good thing. I think as an undergrad, you should figure out something you want to do. You don't have to be 100% on it, but get an idea of what it's like to be in a lab. And then go from there to see if this is your calling. I got into lab work because my old advisor needed help exercising rats, and he was going to do a squat machine. So he was going to have rats do squats. And I just remember going, there's no way you can get a rat to do a squat. And he said, come to my lab and find out. I was like, deal. I came, I saw, I stayed.
So rats can do squats?
Mm-hmm.
Oh my gosh.
And I was going for athletic training at the time.
Oh yeah.
And I missed my course, or I'm sorry, that major was impacted at my university, so that only took like 14 people a year. And I missed the cutoff for round one, and so they're going to go again the next year. And in that time period, I wrapped up one degree, finished off my second degree, and then was accepted to the master's program instead. So I had a rapid change in direction. But I've